All right, we're gonna look at another inverse function, and in this video I just want to focus on what the domain and range are going to be for a little bit. In the original sine function, again, remember the input is an angle and the output would be a ratio. So the domain, as far as x values go, any angle I could enter in there and it's going to be fine. It's going to have a ratio. Now, as far as the range, the output of this function is going to be a ratio. And again, if you think of the unit circle, we're stuck between -1 and 1. The only thing is this function has an amplitude, so that's going to stretch this out. So we're going to multiply both those by 3, so we get -3, 3. Now, there's no vertical shift, so that's not going to impact anything. So there's the domain and range of our original. And again, remember, this is dealing with the angle, and this is dealing with the ratio. Okay, now for your inverse function, which I'm going to solve that in a separate video, but I want to talk about the domain and range here, is typically in a normal function, your domain becomes your range and your range becomes your domain. So they kind of flip, right? So because the domain of the inverse function, right, would be this guy, all right? So -3, 3, because that's dealing with the ratio now, because inverse functions eat up ratios and spit out the angle. Now the range, you can't really go with this, so sometimes it's not even important to even know this. Like in class I said, you really don't care what the original is of this, because you know that the inverse sine function is only defined over here between -pi/2 and pi/2. So you don't really need to, go back and look at this at all. Now, we didn't do one like this in class, so we need to really focus on this a little bit. But if you look right there, this one has some things going on that are going to impact this. If I factor that, so I do 3 sine, take out the 2, x plus, and again, remember this would be like 2 over 2. So I get 2 plus a half, right, and there's my f of x. So if you look at this function, first of all, this 2 is going to impact the period, all right? And this half is going to cause a phase shift. Now remember, it's a -half, whatever causes 0 there. So what I have to do to this is, first of all, I have to take half of it. So multiply by 1/2, kind of like when we fix the 5 key points. So if I multiply this by half, this is actually going to be a 4th there, and a half times that one. My 4's so different there, but that's okay. All right, those are going to both be 4. But then I still am going to impact the angle with my phase shift, which is a -1/2. And so I'm going to have to fix this by subtracting half from both of those. So my new range is going to be -pi/4 minus a half, and then +pi/4, and again minus a half. Again, this is fixed because of how I impacted the period. Again, there's a 2 there, so that's going to impact the period. So I multiply both of those by a half to fix that part. And then I have to fix the phase shift, which again, whatever causes 0 is my phase shift, which is a -1/2, and so I did that to both. So my new domain and range is, there's my new domain, there's my new range. Okay, I'll write another video to actually find the inverse function after this one.